In our lesson today, students will learn how to do the following: make predictions using regression lines, keeping in mind the dangers of extrapolation, calculate and interpret a residual, and interpret the slope and y-intercept of a regression line. To do this, we're going to go back to our pal Barbie and use the data from one of the groups. This group, however, forgot to record their measurement for 5 rubber bands. So we have the data included here, and again, we're missing the one for 5 rubber bands. Let's see how we can start using our analysis with the data that we have that's complete. So we're going to use our applet to make the scatter plot, and then we're going to go from there. So it's important to remember when you go to the applet, we have to make the correct choice as to which one we need to use. So we go to statplet.com and we want to think about what kind of variables are we working with. Are we working with categorical variables or quantitative variables? And so again, if we think about the number of rubber bands and the lowest point the head reaches in centimeters, that would mean that we're talking about 2 quantitative variables. So once we select that, we have to remember, well, what's our explanatory variable and what's our response variable? So for us, with Barbie jumping, we said our explanatory variable was the number of rubber bands, and the response variable was the lowest point Barbie's head reaches. And again, we were measuring in centimeters. So what we're going to do is we're going to enter the data into our applet, just like we've done before with our commas. Since the group forgot to write down the data for 5 rubber bands, we're going to skip it and just use what we have. So we're going to have 0, 1, 2, 3, 4, 6, and 7. And again, we've got 25, 32, 41, 49, 55, 69, and 78. So once we're here, we're going to hit begin analysis. And we can see the scatter plot of our data. So please pause the video and add this to your notes. While you're looking at the scatter plot, a couple of things you want to talk about. One, what direction is it going? And as the number of rubber bands go up, so did the lowest point. So we could say it's a positive relationship. Based on the form, we can see that it looks pretty linear. And then we want to think about the strength. And these data points are pretty aligned. So we're going to say it's very strong. How can we commit ourselves to what the correlation coefficient is? Well, if we scroll down below the scatter plot, we see the calculate correlations. If we click here, it will do the calculations for us. Since it's fairly strong, I would expect a high correlation coefficient. And look, it's 0.999. That's a very strong relationship. Then we also want to look at a couple of other items. Like, what equation could we use to model it? And so since we are saying it's linear, remember when you wrote your linear equations, we typically write them in slope-intercept form. So it would be y equals mx plus b. So again, m being your slope, we anticipate it to be positive. The y-intercept, well, we have it here at 0, right, technically. So even though it doesn't look like it's a y-intercept, it's here on our graph. And so we would have to do some algebraic work to calculate the slope. However, since the data is already stored here, we can calculate a regression model. So we want to click on Calculate Least Squares Regression Line. And if you notice, here is the line that fits our data. We're also going to talk about the equation that it comes from. So right now we're going to skip the residuals for a moment. We'll come back to that later. And so here is the equation. We can see it is in slope-intercept form. When we do our statistical analysis with the statplet, though, notice how they put your y-intercept first and your slope second. That's fine. Y-hat is because we're taking some averages to get this equation. So we're still going to have y-hat to show it's a line of fit. Here is our calculated y-intercept and our calculated slope. We also want to double check too, n is the number of data sets that we have, and we did input 7 pieces of data. S is still representing your standard deviation. of the residuals this time. And I'll go back and show you that at the top. And then here's your correlation coefficient squared, and we'll talk about that in a moment. So you want to write down your equation with these pieces of data onto your lab sheet. All right, let me go back up to the residuals, right? And so we're talking about the residual is a comparison of the actual data values to what our predicted values are. So we're going to look at this as we go through our steps on our lab report. So let's go back to our lab report here. And so we talked about getting our scatter plot, right? And we have our equation to represent it. So this is talking about our predicted y, our response variable, from our given x, which was your explanatory variable. So knowing the rubber bands that I put on my chain, I should have a predicted height of the head reaching for the Barbie. So now if I look at step 2, it says we want to use the regression line to predict the lowest point that the head reaches for 5 rubber bands. Well, 5 rubber bands, is that an explanatory or response variable, x or y? This is an x value. So we're going to just substitute that into our equation, right? Follow over order of operations. So we're going to multiply these together, add it to this value, and that would give us our predicted lowest point, which would be approximately 62.653 centimeters. Again, since we had 3 decimals in our equation, I'm going to keep that when I'm going to my answer. So I look at the 4th and then round accordingly. Our next question says, one of the group members later found the measurement for 5 rubber bands was 64 centimeters. Was the prediction from number 2 too high or too low? So in order to figure this out, we did the prediction being 62.653. They got 64. Well, if I take the difference of those two, 64 from the actual minus our predicted, that's 1.347. So here our prediction was too low by that many centimeters. This is what we call the residual, right? I mentioned that before in the visual when we're looking at our scatter plot. Residuals come from the actual data value minus the predicted data value. So if it's positive, we know that we underestimated. If it was negative, we know we overestimated. Again, we talked about these things first semester. So our next question says we want to predict the lowest points that Barbie's head would reach for 20 rubber bands. And would we trust this prediction more or less than the prediction we made in number 2? Well, anytime I'm predicting, that's just a quick substitution for your explanatory variable. So I'm taking 20 and substituting it in for x, following my order of operations, and I have my calculations. Now, if I wanted to see how close I was, I would look to see in my table. If I had the actual value, I could do the residual and so on. However, my table of values stopped at 7 rubber bands. And so we've got to be careful because at some point we know this model is not going to be a great match, right? So I already knew that I was underestimating for 5 rubber bands. I'm probably going to run into some other prediction error here because I already saw I was doing an underestimate with data that I already know. So this is what we're getting into extrapolation. We've got to think about, well, how trustworthy is our prediction going to be as we get farther and farther away from the data that we collected. So again, we stopped at 7 rubber bands, estimating to 20. We have to kind of take that with a grain of salt and say, well, it might be less trustworthy because we're further away from our data sets. What's the y-intercept of our equation for the regression line, and what does it mean? Well, we know what the y-intercept is, right? So when we have 0 rubber bands, that would tell us typically the height of the Barbie, right? So if I look at the regression, it was the 25.33. So we know when we didn't add any rubber bands, Barbie's predicted height would be 25.33 centimeters. So again, that's an interpretation of the y-intercept. Now, when I actually measured Barbie, according to our data set, her height was 25 centimeters. So there's a small difference, and that's to be expected because it's a line of fit. It's not a terrible difference in the residual, so we're not going to worry about it too much, but we know as we come into play further away from our data set, we have to take that into consideration. And again, because it's a linear equation, we want to know the slope and what does it mean. So remember, slope is the rate of change, right? So if I look at the slope for our residual data point, that's the B, and that's 7.464. What does it mean? Well, every time I increase the one rubber band to my chain, we predict that the increase in the lowest point Barbie is going to reach will go up by 7.46 centimeters, right? So that's our interpretation of the slope. So we have a prediction about every rubber band that we add to the change, how much lower Barbie is going to go. So hopefully there's a lot of review of things that you talked about with your linear equations in Algebra 1, Algebra 2, and pre-calculus. We're just going back and talking about those lines of fit. So if we look at our big ideas, we have the following. Right? We know our least squares regression line is the line of fit, your typical slope-intercept form, right? This is what we're used to seeing algebra class-wise, and this is what we see statistical class-wise. We just have to remember that the further that we go out from our data, we have to be careful of extrapolation. So would it be a good fit? Would it not? Should we have it be trustworthy, less trustworthy, and so on? The residuals are coming from the actual y value that we collected in our experiment to the predicted from our line of fit equation. Okay. Again, if we want to look at the visual for that, if I go back to my stat plot, here is the visual of the residuals, right? So this is kind of measuring from the actual data values. So I'm looking at this vertically. The closer these points are to that zero line, we can see the more accurate they're going to be. If you want to look at it horizontally, it's saying the same thing. So this is looking when the residual matches the actual, and these are the differences when I take them for every single data point. And lastly, we always talk about interpretations, right? So when we're talking about the slope, that's the predicted change in our outputs, our response variable for increasing of 1 for every explanatory variable, whatever that would be. And our y-intercept is always our predicted output, our response variable when our input, our explanatory variable, x is 0. So we also talked about as their starting value in Algebra 1. With those big ideas in mind, you're going to apply them to your application today. Do cut flowers benefit from sugar in the water? So you've got your very detailed description here. We have a scatter plot given to you. We've also got our equation for our line of regression all defined. Based on that information, you're going to talk about finding some predicted values, calculating some residuals, giving me an interpretation of the slope, and your y-intercept. And we'll discuss these things again at our next meeting.